Welcome back. In the last video, we were going through this 15 puzzle challenge, and these challenges, there's these three of them here: rock, paper, scissors, 15 puzzle, and hangman. And the goal is just to come up with basically kind of sketch out a design. You don't need to make the actual game, just come up with a design this suggest CRC cards, which is what we've been doing. And in the last video, we got through rock, paper, scissors, and I also opened a Visual Studio and kind of wrote a little, not all the code, but a few parts of it to sort of illustrate how it might go together when you try and turn that design into code. We also, with the 15 puzzle, we had come up with a design, and here is what I had come up with. And I had made the decision that I want to do the same thing as I did before and just kind of sketch out in code what this could look like. I'm not implementing every single detail, every single method, but just to kind of illustrate just kind of the process of converting that into code. And so this is what we ended up with in terms of design, that there would be a 15 puzzle game that's kind of the manager. This runs the game, and it reaches out to several. These in this case, end up becoming minions of this 15 puzzle game. So it'll reach out to the PlayerInput class to get input from the user. It'll reach out to the renderer, this board renderer class, to have it do the drawing. And it'll reach out to the board class to do a couple of things here. This board class checks to see if the game's over and can track the current state. So we're gonna turn that into code. I'm gonna move this off to the side here so I can still see it, but you guys won't be able to see it on the video. That's okay. And I'm gonna jump over to Visual Studio. Bring that over here so you can see that. Still have my rock, paper, scissors code here, which I'm gonna just Control A and delete, clear the whole thing out. So I'm gonna make a class that's a board class, and again, I don't want to write out all of the code for this. There's a lot of ways that you could handle, representing the board. So tracks the current state. And the state, so this is a board that's got the numbers 1 through 15 and then an open slot. So there's a number of ways that we could represent this, and one of them is we could have, but all of them, because this is a 2D grid, the thing that comes to my mind here is a 2D array. So the type of the 2D array is maybe still to be decided, but I might have a private, and given that these are numbers, I might use int. The catch is something needs to represent the open spot. And I think, so given that the numbers will be 1 through 15, maybe the open spot can just be the number 0. So the whole board will contain the numbers 0 through 15, including the 0 and including the 15. Or maybe we make that number, the open spot, be the 16. Or other possibilities here are we could use, I was going to say characters. I don't know if we could legitimately use characters because the number 15 requires 2 characters. So maybe this could be an array of strings, in which case we could have null could be an option, and that could be our open spots. We could make this be a 2D array of strings, and specifically say they can be null. That's a possibility. We could make an enumeration for it. So we could, for example, come down here and say, so we could do 1, 2, 3, 4. I still love these suggestions. They're often very good and sometimes really weird. Even 5. So I could do that, put in some other ones here and then have like a empty. And that, I think, and actually if I were gonna do that, I'd probably put empty first. So that's another possibility. There's, like I said, there's a lot of ways this could work, and at some level we need to just pick one. So I'm gonna let's assume int for now, and I'm gonna make a decision here. I'm gonna say this is a numbers 1 through 15, and 16 is the open slot. And there's a reason for that in a minute that I'll get to, but yeah, I'll get to that in a minute, why I'm picking 16, though I am thinking that there's a downside to picking 16. All right, so it needs to track the current state. So the one thing about this is I feel like we need to initialize this. I feel like it's worth showing. Equals new int. So this should be a 4x4 board, right? Because it's a 15 puzzle. I mean, you've seen the pictures. I can probably pull that up. It's a 4x4 board, and there's an open slot, so that's what it looks like. And then what we can do is we could do. Again, my intent was not to just write all the code here, but I don't think this is bad. So we can just do. Let's see. So we should probably establish a convention here. Is the first one the row? Is this the row in the column? Or is this X and Y? So this, we're going to say row, column. I'll just make a note of that here, so that I remember it's row and column. So if I do, let's see, row 0, column 1 is 2, squares 0, 2 is 3. Like we could like write all that out and just keep going all the way down to squares row 4. Well, it'd be 3 and 3 equals 16. So that would, like, if we did write all that out, that would give us basically this right here. We said 16 is that empty slot. Like I said, that's an arbitrary choice. It doesn't have to be 16. But we could also, some other possibilities is we could, given how we've set this up, we could just write a loop. We could say, 4 and row equals 0, row less than 4, row plus plus, 4 and column. Squares at row and column equals. This is a little tricky. Row, let's see. So row 1, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a row times 4 plus column plus 1. I will say that kind of logic, it was very tricky for me when I was first learning how to program, and has gotten easier as I have had to do that kind of thing a bunch. So if you couldn't just come up with that, do not worry. It is a tough thing, but with practice it gets easier. All right, let's see. Yeah, so that, that sets up the initial board. It's currently, if we did that, like, it's currently solved, which, by the way, that reminds me of my other thing. So we need a way to track the current state, and I'm gonna bring this back over here. There's something that got missed in this design that I'm thinking about right now, and that is that, like, this says ask the board to change state. So one thing that isn't listed here that maybe should be is somehow we need a mechanism for this board to be able to change state, which starts to bring up a question of what is it like? What does that actually look like? And we didn't answer that here when we sketched this out, in card form. We didn't answer that kind of detail. That's one of the limitations of this like paper-based, or I mean, people will do UML diagrams. That's one of the problems with it is no matter how much time you spend writing out a design like this, you will always end up like it will have to change when this like paper-based design like sketch meets the actual code. There's always going to be details you just didn't think of, some problem that came up, some bug that your design had in it, or maybe it wasn't performant enough, and you got to totally there's no way to know that when you're doing stuff in paper, and you can't know it until you're deep into the code. Which again goes back to my comment earlier that the code is the design. This right here is your actual final like detailed design of how this thing is supposed to work. Everything else besides that is just a guess. So this was our guess, and again, we missed something important, and that is that this thing has to somehow be able to represent the notion of I gotta like somehow convey to the board you got to shift some things around, and that's not a simple thing. And we like I said, we managed to not really, like the closest thing we've got here is ask the board to change state. So that's asking this guy to change state. But what does this thing look like? Like, how does this guy say, I want you to move, slide a tile around, move the, like if we're looking at this, I want you to move the 2 from here to here. So what does that look like? And we probably need to figure it out. So let's talk about that a little bit. I think it's worth the time here. I could imagine this being, like if you're just looking at this, I could imagine us saying we want to convey movement in terms of direction. So we could have a direction, up, down, left, right, and we can think of it in one of two ways. We can think of it, let me zoom in here a little bit, make this bigger. So we can think of it in terms of like a move that is right. Could be we're going to take this thing and move the 2 right in the right direction into the gap. Or alternatively, our mental model could be basically by moving tiles around, we're shifting the open spot around. So a direction of right could be this moves to the right and the 6 moves backward to replace it. So that's a possibility, and either of those I think could be an okay mental model. I think I like the notion of, so if my movement, if the player's movement choice is right, then I think I want to say move something rightward into the open spot. So right in this particular case would mean move the 2 rightward into that open slot. So this should change it like that. So I'm actually gonna skip around here just a little bit. We had in our design this board, which we're not done with in terms of code, but I'm gonna look at this player input. Let's just kind of zoom in on that. So I'm not quite done here, but I'm gonna jump around. So public class player input, and I'm gonna make, so this needs a method, get move. And it's like, this could be something as simple, like one thing I could do here is I could say console.read key, which this returns a console key info, which has that has a bunch of different things in here. So it's got a key character, a key, modifiers. We're getting some of these ones with the star are ones that the IntelliSense has said you're likely to be using this next. And I don't know, like it's usually actually pretty good. It's based on, I think, what you've used recently and what other people typically use. But so we see a lot of the same ones down here. So it would be the key character. So that gives us like the character type. This gives us an enumeration. I'm gonna use that. So we just say console.read key, and actually one thing I want to do is this has another overload intercept. I don't want that to actually display. I just want to get the key, and now this will give us console key. So what I want to do is retrieve that and get it into a variable here so I can work with it. And then I'm going to use a switch. So I'm going to say, what we need to do is we need to convert a console key into a direction. And speaking of direction, we should probably define that. And I'm just going to define this as up, right, down, left, kind of go in a circle. So I'm going to do a switch expression here. I'm actually going to just, I mean, we could put this in a variable and just do, so if it's console key dot left arrow, then the expression should, the value that we get out of this should be, direction dot left. And I'm going to duplicate this a few times. So we want left, right, up, down, now we probably would be well advised to handle the scenario where that isn't the key I pushed. I'm going to skip that. I mean, like I said, the whole purpose here is not to write all the code, but just to kind of give you a flavor of this. So I'm going to ignore the error handling there and just return it. So like now we've kind of established this is how movement is conveyed, which at least partly answers our question. So if we were going to come back here to this board class, and this is our squares, then what we would want to do is we'd want to have public void move and give it a direction. And now this is a little tricky. We somehow would have to like find the location of the magic number 16. And then based on where it is, we would make a move. So for example, we might make a private, I could make a tuple here, just get open location. Anytime there's a method that's called get that starts with get, I always wonder, should that not be a property? So perhaps this is a property that just has a getter that just returns the open location. And we could say for int row equals 0, row is less than 4, row plus plus, for int column equals 0. If square the square we're looking at is the magic number 16, if it is that open spot, then not negative, return row column, so return a tuple. I think you can make a pretty convincing argument here that this shouldn't be a tuple, but we could just make like a public class location and do like a public int row get. So like I think you could do that and then just replace this tuple with the location. And again, our design, like if you look at our design, we didn't mention anything about that, any sort of class that could represent a location. But it does make sense to have it, and I think we might put that to use in other places in the code if we had it. I don't know if that's strictly necessary. Like, this isn't escaping this class. It's just something used right here. Yeah, it's just used right here. So maybe a tuple isn't so bad in this case. One thing we haven't talked about yet is records. I would probably make this a record. That's still in a few more chapters. So that would be a good choice, though. Let's see. So this is saying not all code paths return a value. I really am expecting to find, like, that 16 better be in there. If not, it's a bug. But what do we do if it's not there? I don't love this, but for right now, we could just say return 0, 0. Again, we don't have all the right tools, but if I did have all of my tools, I think I would actually throw new. I think I'd actually throw an exception. Not going to worry about that right now because we don't have the tools to handle it. And like I said, I'm expecting that we're going to find that 16 in there somewhere. The only way we wouldn't have found it is if there was a bug. So we'll just not write any buggy code and everything will be happy. All right. Again, the whole purpose of this is to kind of give some ideas or guidance on how to turn a rough design, not that one, but this one, turn a rough design into functioning code. So like I said, there's a lot of details in here that we could deal with that I'm going to skip for the sake of brevity, because this has already gone on a whole lot longer than I was intending. All right. Anyway, so by like this move, like we take a direction, and what we'd have to do is we'd have to get, well, I can actually unpack this. So I can just call this method that gets the open location and then unpack that immediately into this row and column variable. And now we can say something like, and again, I'm not going to write all these out, but if, so coming back to this, we said if I'm moving, if the open spot is here and I say, I want to move, I'm moving left. So if the direction is left, then I'm moving, the space, sorry, if I'm moving right, then I'm actually going to swap this with the space to the left of it. So that's one column. So this is column 0, this is column 1, this is column 2, 3, this is row 0, 1, 2, 3. And so I'm going to say, let's see, if direction equals direction dot right. So the one thing the one thing we do want to account for here is not that, this. If we're here in the 0 column, then there's nothing to check. There's nothing, we won't be able to move, and so there's nothing to do. So if direction equals right and the column is greater than 0, now we want to actually move the open slot to the left and the whatever's in that spot to the right. Now we could write code in here that does that, something like squares at, let's see, row and column -1 and, oh yeah, actually, so at the target row and column, we want to assign it squares at row and column -1. And then we can say squares at row and column -1 equals 16, because we know that that's what was there. If we wanted to swap arbitrary stuff, we would need to you know, if we wanted, for whatever reason, and this doesn't really make sense in this case, but if we wanted to swap the 4 and the 2, what we'd have to do is we'd have to like remember, like we'd have to like save off the 4 to some other location, update this value to the 2, and then update this one to the place that we stored off. So you'd have to have like a temporary variable in there. Or you know what? There's another possibility here, and that is we could use, so that's, okay, this is one way we could do it. Now, as I'm thinking of it, we could do it, speaking of the duplication, row, column, and that's, I don't think that's going to work. It won't. All right. So anyway, there's that. One thing we could do is we could say maybe this belongs in its own method. So private, it doesn't need to be public. Again, whenever you see like a digit at the end of these, you should be thinking, does this deserve to be an array or some, you know, is there a better name for it? And there probably is. And for example, if we did make, and I deleted it, but if we did have that, like, I don't remember what I called it, like a location or coordinate or something like that. If I had that class, you know, instead of this tuple, I could, that might be a better choice here to just have 2 of these. I'm going to keep going with this just a little bit longer, but so like I could do, if I wanted to just swap arbitrary stuff, I could do something like row 1. I got to save. And squares at row 1, column 1 equals the current value in the second location, and then now squares at row 2, column 2 equals the temporary value. And there, they are swapped. So now in theory, I could just say swap row, column, -1. And now I just need 4 of these. And column is less than 3. And I'm doing a lot more on this than I expected to see. I want to swap it with the row and the column. And let's see, I got to think this through. So we said we're moving, like, if we say right here, we're moving something rightward into the open slot. So up would mean we're moving something upward into the open slot. So up, we need to be careful about the bottom end. So if row is less than 3, row is greater than 0, I will say there is a fairly, like I haven't ran this. I'm probably not going to. There's a pretty high probability that there's some bug in all these numbers and everything, and you'd have to be very careful and check carefully to make sure that everything's moving as you'd expect. But right now, again, I'm dealing with generalizations, and I think that's all I'm going to have time for. So again, we're way deeper into this than I had meant to be. Let's jump back over to this. So we are able to move. We are able to track the current state. We just don't know if the game is over, which I think could be something as simple as like a public bool is over property. And here, so in this case, like the check we would do is basically basically this. So we just iterate through all the rows and all the columns. And because we said that last one should be, the last one should be 16, then what we can do is we can say, this logic that I used to initialize it is basically the same thing that I would use to check it. So if that does not equal, so I'm looking, basically what I'm going to look for here is anything that is not in the correct order. I want to fail. So if I find anything that isn't what it was supposed to be, then return false. We haven't, it's not over. Otherwise, if we look through the whole thing and we don't find it, then it is over. And again, that logic is two loops to walk across the entire 2D array, an if statement to check and see if we found something out of order. And okay, so the board class is pretty much done. This player class is pretty much done. And what else is left? The renderer. I mean, we could keep this again. This renderer class is probably the easiest. I think I call that board renderer. Probably one of the easiest things to do, but there is one catch here, and that is somehow we have to be able to tell this board renderer to draw the current state of the board. So, and did we have that in here? I hope we did. Yeah, so this has, one of its collaborators is the board. In order for it to do its job, it has to know about the board. So how is it going to find out about it? There's a couple of ways we can do that, and one of them is, well, so one possibility here is this. There is so let's stick with one possibility here is we could pass in the board to draw. So passing in its collaborator as a constructor, as a method parameter may be all we actually need to do. That's really easy for us to have here. And now all this guy has to do is like something like, again, the same kind of double loop. But instead of that, we would do something like console dot. This is going to have to be more complicated here, but I need my curly braces. I'm going to need some curly braces. Console dot write. Oh, let's see. I'm gonna not remember the details on this because I don't do it that often. But we could write board. Oh, you know what? Somehow we got to get the data out of the board. This doesn't have it. It has this. It's private. This is actually saying I can make it read only, and I can. Let's do that. Somehow we have to be able to ask the board for, well, what's in a specific square if we want the board renderer to handle that. We need, so yeah, so if we want to keep the responsibility for drawing separated from the board itself, then you got to be able to ask the board what's in square, at 0, 0, what's at 2, 3. So we could make this public, and then this class could just directly access the squares array. The catch there is I don't want this to be public because that would allow somebody on purpose or an accident to just reach in here and just change it. Like put whatever, that somebody could write code that would just put -2 across the whole board. I don't really want to allow for that possibility. So it probably makes sense to have something like that. By the way, this is now like, how many times now have we seen that pairing of row and column? We see it there, we see it here, we see it here ×2, we see it here. So more and more I'm thinking that it actually is making sense to define that concept of like a coordinate or a location. It would make a lot of sense here. And I'm not going to do it once again, even though there's plenty of evidence that says we should. But the reason I'm not doing it is because my intent is to come up with the high level design. This isn't even really a part of the challenge. All right. Let's see. So I'm not sure I've done this right. I don't do this very often. And I could look in the book itself because I remember where this is. It's not there. A little later. Oh, or is it? It's right here towards the end somewhere. What did I do? A colon? I think, well, this. Yeah, so I think it is a colon and then 2 zeros. I think I got that right. So I think this will display, no matter what, if it's a 2, it'll leave us, it'll reserve space for 2 characters, but the first one will just be empty, and then the next one will be the actual value. And if it's like, say, 15, then it'll just be 15. And then I want this last space at the end. So actually, let's put that down here at the end of the loop. So we'll just, go down the list and leave a space between them. And we could get a lot fancier with this. Like, I've seen a lot of people draw like a border around it using, something like, this kind of thing. Keep going. This is what we've got here. Doesn't have that grid, but it's otherwise about the same. So there's a lot you can do with that. I'm going to leave that out right now. All right, so board renderer, I think, is fairly straightforward. The other possibility here, we were talking about this and how this could get a hold of its collaborators. The other possibility would be to have that be passed in as a constructor parameter. And then we don't have to pass it every time. It can just be given to it once. But that means now a board renderer instance is very closely tied to a board instance. Like you can't change that after the fact. It renders its board. It renders the board it knows about. In this case, we could ask it to render 17 boards in a row if we wanted to, 17 different boards. Either one could work. Yeah. So now the last thing we've gotten here would be this 15 puzzle game that knows about all those things and just runs it. And again, I'm just going to sketch this out really fast. I'm going to just make, again, just like a run method that just it makes a board renderer, it makes a board. It what else does it need? It gets a player input. And of course here, if we did pass this in with a constructor dependency, then we would construct the board first and then hand off that board right in here and the constructor to it. So we make all of our minions that we need to run the game, and then we do public. Now we got our game. Well, somehow we got to start, and I think we did. I think we actually did identify that. Randomize the starting state. Again, I'm gonna I'm going to not worry too much about this initially, other than to say that if we start with this board, like this already has a move with a direction. So we could use a random object, which is something we haven't talked about, but it's coming by the end of part 2. Not that it's that hard to figure out and use, but so, you know, something like for int iteration is 0. Do something like random next. Just cast that to a direction. So now we have a all right, let me take a step back. So pick a random number between 0 and 3. We cast that to this direction enumeration, which is, you know, if it's 0, then this will be up. If it's 1, it'll be right. If it's down, it'll be 2. Sorry, if it's 2, it'll be down. If it's 3, it'll be left. And then, so we do that, and then we just say board.move to move. So we just do that 10 times. Well, let's crank that number up. We do 1,000 random moves. We know the game is solvable. That's actually one of the interesting things about 15 Puzzle is if you come in here, oh, I've lost it. If you took all these tiles out and then put them back in random order, there's no guarantees that it is a solvable puzzle. They have to be in a specific order. If you get it backwards, it becomes unsolvable. Instead, what you can do is you can leave this spot up here, you know, so you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You could leave the open spot up here in the top corner. So it's possible to make a non-solvable 15 puzzle by just simply randomly picking numbers. So in my mind, that's a pretty good way to do it, is to just take a solved puzzle, make a, you know, some number of random moves, and we know it's solvable. We at least within 1,000 moves, it's solvable. Realistically, it's probably solvable a lot faster than that, but anyway. So yeah, randomize, and then we just say while not board dot is over, and we just say input dot get move, and then we say board dot move, and then we say we should probably render first. Anyway, that something like that actually should get us, and then down here we can just say console dot. You win. Maybe we draw the board again here just to show it in its solved state. Now, the only thing that we're missing here is we just need to do new 15 puzzle game dot run. We just need to start it. So that's our main method. And I'm going to run this. Like I said, we've done 0 checking of anything already. I don't know that this is actually going to work. All right, well, this is what it did. Board. Clearly, I've got a bug in here. And I think I can do. That's what I meant to do. Board.get square row column. By the way, I wanted to use the square brackets to do indexing. C# lets you do that. It lets you define what the square brackets mean for your type. So you can do that if you want, but that's not until quite a bit later in the book. They're called indexers. And it's covered in the operator overloading level. All right, let's try this again. I don't want to spend a lot of time debugging it. It'd be nice to see it mostly work, though. Oh. It's got zeros on there. I wasn't expecting that. I was expecting, let's see. I think it's the number sign. That's still not quite what I was looking for. One thing I do want to do here is say console.clear. So now I push the arrow keys. The other thing is the other thing to be nice here is something like if board.get square. So if it's our magic number, console.write else. Again, once our for loop ends up with that many lines in it, even though I think it technically works, I like having that. All right, so now I've got an open, yeah, that looks a lot better because now I got an open slot and I'm just sitting here moving these around in a circle. Where's the 4? Oh, it's all the way down there. We got these backwards. All right, I'm gonna stop here. You can kind of see, like I got this first row backwards. I don't remember the strategy for beating this anymore. Somehow I got to flip those around. But that's the gist of it. We have a mostly working game. I think if I push not an arrow key, it's gonna blow up on me. Yep. Anyway, so I think that's enough for this. Like I said, that's the gist. It's something about like that. Like I said, we're using a couple of little tools in here, in particular this random that we haven't actually seen. But that's kind of the gist of it. And like I said, this design mostly held true. We did make a couple of little changes. Like I said, in retrospect, I think it would make sense to have that data structure that is like a coordinate. We didn't identify that when we were doing this design, but I think it would make sense. Yeah, so that is enough of this 15 puzzle one. Let's move on to the last one, which is Hangman. And it gives us a very detailed, this is what this should look like. Sorry. And a description here. So the game picks a word at random from a list of words. The game states displayed to the player as shown above. The player can pick, so note the things that are needed in here. We need to know what the word is. We need to be able to display it. We need to know how many moves we've got left. We need to know, a collection of the incorrect things that we've got, and then this is input over here, this E. So we need to allow them to make a guess and then fill it in. So the game picks a word at random. The game states displayed like that. The player can pick a letter. If they pick a letter they already chose, pick again. So we need to be able to remember the things they did choose. The game should update its state based on the letter the player picked. The game needs to detect a win for a player, and it needs to be able to detect a loss. And again, use CRC cards. We don't need to actually create the code. We'll probably do a little bit of code before we're all done. Once again, I'm going to take all of this and just move it off to the side and just start over. So let's see. The first one, the game picks a word at random from a list of words. So there's a couple of concepts in there, and one of them is a random list of words. So it seems like we need some sort of word dictionary contains a list of words. I don't know that this has any collaborator specifically, so I think we can do that. And then it says the game picks a word at random. So we're already talking about this concept of a game. And we already saw in the other two, like it has been very common to have something that represents the game state as a whole. And by the way, that I don't think is something that is limited to just games. I think in general, most applications will end up with a class that kind of represents the beating heart of the application. And that could, in all the programs we've done kind of in the past, that's very often been the program class that our main method lives in that just gets generated for us. So when we have a very small program, it could be just that. In other cases, we end up with a specific separate distinct class for it. But I'm gonna like kind of like what we've already seen. So we're at this point, there's some lessons we've learned from doing this before, but I'm just gonna go ahead right now and make a Hangman game class. And so now the next thing here is, so the game picks a word at random. We need to assign that responsibility to pick a word at random. And this says the game picks a word at random. That doesn't mean this Hangman game must do it, but I think it makes sense to do that there. And then so this guy's going to have the dictionary as a collaborator. So we're not going to talk about how this guy gets his words yet, but he'll just have a list of words. That's just what he's going to provide to the rest of the world. All right, the game state is displayed to the player as shown above. So again, like looking at this, like a single line here, the state of the game require, like we have a specific word, like a chosen word. We have a number of guesses remaining. We have a list of incorrect guesses and also potentially guessed letters. Like down in here, we have, well, let me pick a different one, right? But by the time we display this, the user has already guessed E, I, U, O, A, T, and S. So somehow we need to be able to keep track of a list of all of the guessed words, guessed letters. So that's a whole bunch of state, and somebody's got to keep track of that. So let's figure out whose job it is to hold on to all of that. I'm gonna go out on what I feel like is a fairly short limb here and say tracks game state. So word to guess, remaining guesses, and guessed letters. So, and let's see, the game state is displayed to the player as shown above. So in addition to that, this one item about displaying state, something's got to handle that. Now, word dictionary doesn't make sense. I think this Hangman game could make sense. We could give it the responsibility of, the extra responsibility of saying, you're going to display the game. But kind of as we've done before, maybe it makes sense to, have a GameRenderer class. In order for this to, so then that means this responsibility is draw the game's state. In order for it to do that, he's going to have to know about the thing that has that information, which is this right here. So he's going to have to know about this guy. But this guy is also going to have to, kind of like we've seen before, he's going to have to run the game loop, which includes display the game. So he is also going to have a game renderer. So they need to know about each other somehow. So we'll have to deal with that. The fact that these two guys have to know about each other. Let's see. So the player can pick a letter. If they pick a letter they already chose, pick again. All right. So we, again, it makes sense to have a class in here. Some of these are ending up very similar to others. Let me move that out of the way and grab all this stuff. All right, so this get a letter from the player, and so the player can pick a letter. If they pick a letter they already chose, pick again. So that means that something has to be keeping track of letters that have been chosen already. And I think maybe this guy, like, either this guy needs to know I guess he already has to know the guest letter. So maybe it makes sense for him to like, if he's keeping track of that, then either this guy needs to ask him if a letter's been guessed before. So that means he would have to know about the Hangman game, or he would keep track of it himself. So he could this class could, that's another possibility here, is track remember guest letters. Which maybe if we're going to do that, like remember the guest letters, maybe this could be, let's see, word to guess the remaining guess. I'm going to rephrase this a little bit. Count which letters have been revealed and which letters were wrong. That's starting, like, I've written out a lot of text there. It's starting to get long. But that's the idea, is this guy keeps track of just any letter that has been guessed. He'll remember that. So he has the ability to ask the user to, no, you've already said that. You've already said that. You've already said that. Guess again. This guy over here, meanwhile, has put them in the category of wrong letters. So there is some duplication there, and maybe we should, like, maybe it makes sense to get rid of that. I don't know how much that's going to matter. Let's see. So the game should update its state based on the letter the player picked. So I think that's part of this run the game loop. So I'm just going to put that responsibility right in here and say update state. Oh, ask user for letter and update game state. And then the last two, the game needs to detect a win for the player, and the game needs to detect a loss for the player. Until win or lose. So I'm just going to throw that in there, and I think, like, this guy's doing a ton of work. And maybe there's a way to break it out, but I don't know. I don't feel too bad about that. So once again, this guy ends up, he has these other things that they each do their own job. but there, yeah, as always, there's a lot of different variations on this. As I'm thinking about it, I kind of wouldn't mind. I kind of wouldn't mind getting rid of that responsibility and shifting it over to here and do something like can pick a random word. And then to make another card here that represents that the main method. So program or main, and this guy, let's see. So this guy is going to, so what I'm going to do here is rearrange some stuff a little bit. So he's not going to know about a game renderer. He's going to know about the dictionary. Gets a random word and starts a new game. So I'm actually we're gonna end up with an extra level in here. So I'm just shifting some responsibilities around is really all I'm doing. And so at this point, what I'm expecting is this guy's gonna start a new game with this random word. So he's just gonna be given the word to guess. And if we play a second game, then we'd make a new instance of Hangman game. So this guy does need to know about this word. Oops. This word dictionary. The program class needs to know about it, but the Hangman game doesn't. And now in this case, like maybe these just kind of live under here. So hopefully that makes a certain amount of sense. And once again, we're gonna, like I said, this is all the thing actually asks you for. This is all it actually demands. So we are technically done at this point and could move on. But let's, because the whole purpose of these 3 challenges are just to like experiment and just explore and get your hands on like in your brain wrapped around this idea of how could we structure this code? What things, where are the classes? What are some of these things that could exist? And like I said, you're likely, like you're going to get it wrong a bunch. But for the most part, like if you're working on it and you say, you know what, this was wrong, I'm going to change it. You just come in here and you just change it. It's really easy to change this stuff. On the other hand, if you get into the code and realize it's wrong, well, you still can just change your mind. Like nothing's locked in stone ever. That's why software is soft. But again, let's delete this and just kind of move my design out of the way here. And we'll just kind of start working through this. So I could have a class that's like public class. I'm gonna start with that word dictionary class. And this contains a list of words, but it can pick a random word. So this needs that capability. Get random word. So if I were going to write out this code for real, if I were going to make a real Hangman game, what I would want to do is go on the internet and find a nice like happy list of words in a text file. 1 word per line. And then I would use some stuff that we're still coming to in, I don't know, what's maybe level 35 or level 36 that deals with like file input and output. And I would just open up the file and read it all in and then pick a word, or maybe I'd stream it. I don't know. There's a lot of options there. In this case, I'm going to take a shortcut, and we could do something like we talked about this earlier. We haven't, like, the book has not talked about the random class yet, so it's this is jumping ahead a little bit, but I could do something like that's the thing about these is most of these challenges that we've got here are technically like the easy way to do most of this stuff demands knowing more of C# than what you actually have knowledge for, which is why I've specifically said you don't need to actually write out all this code. But I've seen a lot of people who have just said, I'm just going to do it anyway. It's good practice. I'm actually going to use a switch expression. Oops. So if it's a, let's see, we're gonna limit ourselves. So if it's 0, we're gonna return. I'm just gonna pick. Apparently it's dinner time. Except it's not. I just ate. All right, so obviously our list of words is very, very small here. We're limited to 5 choices. And if we already know that this is what the code does, this Hangman game is going to be very easy because I'll be able to pick A, and I will instantly know if it's one of these 3. And actually based on the length, so we'll have that, I'll know. Actually, based on just the length. Oh, no, this one has an A in the second spot too. Anyway, this is really easy to, so I can guess A and then C, and then I just know the word. If my word choice, if my options are very limited, it's not hard to figure this out. Anyway, so I think that actually is enough for a very, very primitive version of Get Random Word. Like I said, I would ideally use a file to get access to a very big pile of word options. And then what we can do here is we can just say, so in our main method, we can just say new word dictionary dot, and I'm not even going to store it in a variable. I'm just going to create it and then immediately ask it to get a random word. And all right. And then this is supposed to start a new game. Oops. No parentheses there. But if I'm gonna hand this a word to start with, then it makes sense to pass that in. And if you remember, there were a lot of little things in here. Let's see. Track the game state, the word to guess, the remaining guess count, which letters have been revealed, and which letters were wrong. So let's add all of that state. So private word to guess. We'll just assign that its value here. And then we need the remaining guess count, which is just going to be 5. So private int remaining guesses. Private int. Sorry. Private. Okay, so which letters have been revealed and which letters were wrong. So which letters have been revealed? That's based on the letters in this. So I think this is like a Boolean array. Has been revealed. And then maybe down in here we would do has been revealed equals new Boolean array, and we just use exactly what it's suggesting there, the word to guess.length. And then let's see, we want those to all default to false. Nothing should have been revealed. But so the default value for a bool is false. I was going to say we need to iterate down the list and set them all to false, but technically speaking, we won't need to do that. They'll all default to false. Let's see. Which letters have been revealed? So we've got that, and then which letters were wrong. Now this is going to get interesting. We need some way to represent, to have like a list of letters that are wrong. So we could do something like private wrong guesses. We could do that, and we have no like it's empty to start. That's gonna cause us a little bit of pain as we get going, just because it's not easy to just like add new items to an array. It doesn't actually work that way. But leave it like that for a minute. We'll solve that problem later, maybe. And then run the game loop until we win or lose. Yeah. So while not, so we need this. It needs to be able to tell if we've won, has won, and not has lost. Keep going forever. That's a couple of properties that I just invented. You know what? I think I'm just going to make these be methods. I think that's a little simpler here. So public pool has one. So while not has won and not has lost. So if either of those, let's see. Yeah. If we have neither won nor lost, we're just going to keep going and display the game and ask the user for a letter and update the state of the game. There's quite a bit involved in that. Has lost comes down to return remaining guesses equals 0. And then has won is return actually we could do a for each loop here. For each if not has been so if we find one that has not been revealed, return false. If we get through that whole loop, we haven't found one, then we can return true. All right, so has won, has lost. So those are, I guess I don't know that they're bug free, but they, that we got the gist in there. And then we need to display the state of the game, so we can make another class in here that's public class game renderer. So we were talking earlier about how the Hangman game, it has this game renderer, and he has to know about this, and this guy has to know about this, and that's because this guy has the responsibility of telling the renderer when to run, and this guy he needs this guy's data to draw the state of the game. So that's why they need to know about each other. And like I said, there are a lot of ways for two classes to learn about each other. You need a reference in order to do anything with it. But in this case, a way to do it is this guy can create a new instance. So he can just say new, well, let's hang on to it. Game renderer render equals new game renderer. So he'll just create a new instance. That's how he's going to get a hold of that, is he just makes the thing. And then dot render, and what we'll do is we'll pass in the main Hangman game. We'll pass in this. So that's how in this case, that's how they'll learn about each other. There's a lot of other ways you could do it. For example, we could do a constructor dependency, like we could have passed it in here instead if we had wanted to. But now, so at this point now, this guy technically has access to its stuff, although all of these are private. So we would need to make some sort of access to it. Or alternatively, we could just shove the rendering back into the Hangman game. And I like having it separated. I think that's a good idea. So I am gonna do this. I'm gonna upgrade this to a public property, a property with a public getter and a private setter, which means I'm gonna have to change this. And I'm gonna upgrade this to same thing, public bool has been revealed. And we also want this to be a public, same thing here. So I'm just going to make this the number of remaining guesses. And probably same with this guy here too. This one I'm actually not going to have a private setter. We don't need to change this word once it exists. All right, so there. There is a danger here. This guy gets access to this array, and theoretically, even though we kind of want this guy, Hangman Game, to manage this array, it's by this getter is going to return that bool, that Boolean array, and somebody could technically stomp on it. They could go into the value. They're not going to be able to like reassign the whole array to something different because the setter's private, but they could technically change anything they wanted there. They could go through and reveal all these words. That might be an argument for doing something else in terms of design here, and there's a lot of other choices, but I'm not going to get into that right now. I'll leave it alone, and we'll just say, let's just trust ourselves for the next 20 minutes and make sure this just works well. So now at this point, we ought to be able to do something like console.writeLine. Console.write word : and for each character in, well, actually we want to game.word2guess.length index ++. If game dot has been revealed at that index, so if that index has been revealed, then what we want to do is console.write game.word2guess at the same index. Otherwise, we want to do console.write game.word. Otherwise, we want to just do an underscore, a blank. And then we do console.write a blank space between each letter. So this will display all of our letters, which if I bring this back onto the screen here, so that should get us through all of this. And then we want to do vertical bar remaining, vertical bar incorrect. So console.write a vertical bar and a space, remaining. I'm just going to keep going here. Use some string interpolation, game dot remaining guesses. Vertical bar incorrect. And now we need to do for each and game dot wrong guesses. Write the letter. One thing I'm going to say is that a lot, these are all generally should be, well, yeah. These are all uppercase. All of these are uppercase. These are uppercase. I happen to type in lowercase, and in this context, E versus I versus O, like it doesn't matter if they're upper or lower. It just matters if it's a different thing. So maybe what we want to do is let's just call that to upper. So now we've got only uppercase letters. All right, so where's our loop? Where did that loop go? So render.render, and then we need to say, you know what? Where did that go? So player input, get a letter from the player. Remember guest letters. All right, so we do need to make that class. We don't have that yet. So public class, player input, public character, get guess. Return, convert dot to character, console dot read line. So I mean that's the poor man's version of it, other than the thing specifically requires that we don't have that. If it's already been guessed, we remember that and ask again. I'm going to skip that for the moment, and we'll come back to that later. Again, the purpose here is just to have something working rather than the design is the important bit, not completely solving it. So let's see. The player can pick a letter. If they pick a letter that already chose, pick again. So the game should update its state based on the letter the player picked. So similar thing here. We just player input equals new player input. And then down here we can say input dot get yes. And actually no. Okay. So whose job should it be to make sure this is an uppercase letter? I think you could make an argument that maybe should be this guy. So actually, if we just do this right here, to upper, that should be enough to ensure we've got an uppercase letter. So at this point, we should know this should be an uppercase letter. And now the tricky part, update the state of the game. So what we can do is we can say for each, we're going to need a for So, okay, so we're going to iterate down the whole word to guess. And if word to guess at that index equals the guess, then we're going to say has been revealed at that same index is true. So if it's there, we switch it to true. If it's already been guessed, like we didn't actually do anything to prevent ourselves from picking the same word again. In this case, if we, that isn't going to do us any harm, even if this is a letter we've already guessed. And then what we would need to do here, the last piece here is we need to know if we need to add it to the wrong guesses. So let's do this. Let's make a variable that can tell us if we revealed something. We'll assume that we haven't revealed something, but as we're going down this list, if we get to a point right here where we do reveal something, then we will say revealed something is true. And when we're done, then we can say if not revealed something, then we will say remaining guesses minus minus. And well, we need to add it to our list of failed guesses. I'm going to leave that out for a moment. But at this point, let's see. At this point, all we would need to do is say new Hangman game with the word dot run. At this point, like we've actually got a mostly working version of this, and I don't know what's going to happen when we run this. Who knows what it'll crash. We'll see what it does. Just finished. I will bet that one of these did we start our remaining guesses? It didn't. I'll bet it was that. It said we were out of guesses. Yeah, that's a lot better. Guess A. E. Was there really a word that had that many E's in it, or is that a bug? I no longer remember. Cheesecake. Okay, well, we probably know at this point that it's cheesecake. So it is, like, I guessed it wrong. We haven't populated this list here, but, like, it looks right. Let's see. And it'd be not, like, we could make this better by showing the final solution as well. There's a handful of little things that we can do here, including that. All right, so let's see. The last thing I want to mention here, we haven't. Arrays are slightly problematic because they don't have a natural way to just grow them, and the book does mention that. However, like, this is a case where it would sure be nice if we could grow our array. This wrong guesses, we need that. Like, this one here isn't going to change. Like, we'll be able to create it once and we'll be good. This wrong guesses, we know we're going to need to be able to do stuff. So let's see if we can find an option here. I think this is probably, so what we need is, if we're gonna do this, we need to copy the contents of the array into a new array that's slightly bigger. So wrong guesses. Let's see. We'll do update it. So we'll make a local variable that is slightly larger than the a new character array that is one longer than the existing one. And then we will use the array.copy2 method. Let's see. Let's make sure this is working. It's not copy2, it's just copy. Copy. There's a bunch of overloads here. But there is a this is the one we're looking for. So the source array is wrong guesses. The destination array is the updated one. And then the length is going to be wrong guesses length. So this will copy over all of the items that are in here over to here up through the length, which leaves the last spot empty. But what we can do is we can say updated wrong guesses at the last spot equals the guess. And then the last step we need to do here is we need to say wrong guesses equals the updated wrong guesses. All right. So let me walk through that again really quick. So obviously at this point we didn't reveal anything. We subtract 1 from the remaining guesses. And then we want to add on to the end of the array the letter that was wrong. Since arrays can't just get a little more memory, a little more space for one more item, what we're doing here is we create a whole new array. That's what happens here. That's slightly longer, one item longer. Array.copy moves everything over, goes down the whole list and copies everything over one at a time for this many items. And then this is, remember, that's the, what is that called? It's like a index from the end. That'll get the, so we assign the last spot in that new array, the guess, and then since that hasn't affected this wrong guesses list yet, it's been all that's been working with a local variable. Now we update our field in the class to be that new one. So now we should be able to run that. Let's try this again. So where you can see this little collection of stuff is growing. It would be nice to be able to show the final result, or to just say, hey, yes, you got the word. It was taco. All right, there's an alternative to this because that's a lot of stuff. And again, this deals with stuff that we haven't specifically talked about. And that is we could use one thing is we could just make this concept, we could just go make a class that just does this for us. And the reason I say that is that having this like growable array would also be nice in here. We didn't handle this, but we're supposed to handle, if we've already guessed the letter, tell them to guess again. So we do a similar thing here. We'd have a character array that we'd need to grow over time. However, a sneak peek of what can be, there is a thing that we're going to learn about in the relatively near future called the list that will just kind of handle this better. This is a kind of like an array, but they can resize easily. This uses generics, which is a topic we're almost ready to learn about, but maybe not quite yet. But I think you can see the concept there. So, and at this point, we don't have to do any of this. We can just say wrong guesses.add. So that's way simpler code to use that. Okay. So that's basically it. I mean, again, the whole purpose of this was actually not to build the whole thing. And we've left a few loose ends here. But it was really just to come up with this. And again, I think in general we ended up using this design more or less as it was. I think had we gone and made that other class to like handle like the growable collection, like a growable characters class, we might have wanted to put that in to the player input and to the Hangman game as a collaborator, because they would have had one of those. Each of those would have had one of those. Anyway, this video's gone on for quite a while, and I think I'm going to wrap it up here. But yeah, so and again, so yeah, this is the design I came up with, and you can see my other designs up here for 15 puzzle and for the rock paper scissors one. Your designs are likely to be very, very different than mine. That is completely fine. It doesn't matter that they're different. This is just a chance to begin thinking about, well, how could I structure this? Like this, our programs at this point are starting to get bigger and bigger. And we can't just pack everything into a single gigantic method, or even a method and a few other helper methods. Like these programs are getting bigger, and we need tools to break down these larger programs into bite-sized chunks that we can work on and use as individual elements. And that's where classes and objects come into play, is it allows us to break that down and to be able to focus on a single, chunk at a time and make sure that chunk is working well, and then make sure it's able to interact with things around it in meaningful ways. And so, like I said, the whole purpose of this is just to sit down and force yourself to spend a little bit of time thinking through each of these games: 15 puzzle, rock paper scissors, Hangman. None of them are crazy difficult, but again, you can, like, each of these have ended up being a couple hundred lines of code when they actually turn into code. Oh, I said a couple hundred. 99. We're not quite even to 100 here, but these are getting to be relatively big programs. And so to be able to think through, like, well, what does it mean to be able to like handle rendering? We're gonna pull that whole thing off and do rendering. We're gonna pull this player input off, and we're just gonna focus on what does player input look like, and it breaks the large thing down into small chunks that are bite-sized, things that we can actually work through, and then potentially reuse. We haven't done, there's not, in all of this, there's not a ton of reuse. I think the Hangman or the rock paper scissors one, we had 2 instances of the player class. But anyway, like I said, that's the whole point right now, is it doesn't really matter what you come up with as much as it does that you sit down and just start thinking through, I've got a non-trivial problem. How could I structure this? And as long as you're doing that much, then you're going to be fine. You're going to be in good shape. The step beyond that is to start looking at, as you take a guess about how you want to structure the code, when you actually get into the code and write it, to start to say, well, what parts of what I did worked? What parts are clearly problematic? So that the next time you do it, you have better ideas of what might or might not work. So again, it doesn't matter if yours is different. Different doesn't make it worse or wrong. It just makes it different. And I think if with all 3 of these, I think if I went to, for instance, some of my coworkers and I said, hey, can you make this? Make Hangman in code, in C#. I think I would get some wildly different structures. I think there would be some very, very different possibilities here. So anyway, I think we're done now with everything but Hangman, or not Hangman, everything but tic-tac-toe, which is the final thing here. And that one does ask us to get into the nitty-gritty and actually build it. Though on these videos, we've actually done that. It hasn't just been like a design like this. We've actually 90%, 80% written the whole program. Again, in this case, we happen to use a couple of things like that list class that we haven't actually seen. We used the random before. Well, we use that here too, I think. Like we don't officially know those tools yet, but we'll learn them soon enough. Anyway, that I think will do it for this video. So thanks for joining me, and I will see you next time when we actually take on the final one here, which is tic-tac-toe. See you then.